Welcome to Brain Vision.
Well, we have the mass of the astronaut. Mass of the astronaut is equal to 68.5 kilogram. The mass of the tool is 2.25 kilogram. Mass of the tool is equal to 2.25 kilogram, and its speed after it is thrown is 3.20 meter per second. So speed of the tool is equal to 3.20 meter per second. Well, we know that the total momentum of a system is the vector sum of the momenta of the individual particles that make up the system. Therefore, total momentum is equal to PA, right, plus PP plus so on. And let's call this equation number 1, right? And we also know that momentum is equal to mass times velocity. Well, this is equation number 2. Well, we also know that for an isolated system, the momentum of the system is conserved. So momentum P is equal to a constant, right? So the momentum does not change. Okay, since the astronaut is in space, and assuming that the cord holding a head to the space station is not tight, then the system, astronaut and tool is isolated. So we have P1 is equal to 0. And applying the conservation of momentum, the momentum of the system after throwing the tool is also 0. So P2 is equal to 0. Let's say this is equation number 3. Well, we plug our values for Vt and Mt into equation number 2. So momentum of the tool is equal to 2.25 into 3.20. So that is equal to 7.20 kilogram meter per second. And from equation number 1 and equation number 3, we have momentum of astronaut plus momentum of tool is equal to 0. And further, momentum of astronaut plus momentum of tool, that is 7.20, is equal to 0. And momentum of astronaut is equal to minus 7.20 kilogram meter per second, right? Now we plug our values for PA and MA into equation number 2, right? So we get minus 7.20 is equal to 68.5 times VA, right? So speed of astronaut is equal to minus 0.105 meter per second. That's opposite to the tool.